Okay, good evening, all, and welcome to our program this evening, November 16th, Home Improvement on a Warming World, sponsored by Metro West Climate Solutions Group. I am Jeff Barstell. I am a member of the steering committee, and we are delighted that so many of you could join us on this cold November evening. Metro West Climate Solutions, or MCS, as we have started calling it, is a growing partnership of organizations and congregations in the region, including First Parish in Wayland, First Parish Church in Weston, First Parish in Lincoln, the Congregational Church of Weston, Sustainable Weston Action Group, and a growing list of other community groups and individuals. If you are interested in learning more about how we gather and how we plan these programs, feel free to reach out to us after the program or through our website. One of us who's on the steering committee would be happy to speak with you. Our mission, MCS's mission, is to encourage sustainable, resilient, and equitable action and host timely and relevant programs that inspire and inform all of us, people and communities, to get involved in bringing about solutions. And as I noted, you can learn more about us and our programs at metrowestclimatesolutions.org. Tonight's program was inspired by both global urgency and local necessity. As the latest Conference of Parties climate meeting concludes in Glasgow, Scotland, the majority of the world's nations are coming to terms with the science of climate change and the urgent drive to reduce carbon emissions by 40 to 50% by 2030 and 90% or more, close to 100% by 2050, based on 2005 levels as a benchmark. In essence, we have 28 short years to decarbonize our societies, our economies, and our lives around the world at a rate and in a way that requires historically unprecedented changes and initiatives. When we pair the global urgency described by the Intergovernmental Panel on Climate Change with thinking about our everyday lives and homes, sometimes the questions and issues can be both intimidating and bewildering, even paralyzing. All of us need to make inevitable improvements and alterations to our property that we own. How do we do that while mitigating climate change? How do we go about a renovation or a home improvement project given the needs to stave off the worst impacts of a warming world? That's a lot of pressure on a homeowner. Well, tonight, we are hosting 3 local property owners who will share their efforts to make their homes more energy efficient, less carbon intensive, and better able to ride out the impending changes that are coming with respect to the types of energy we use and consume, at least here in North America. They will share their hopes, their challenges, and the key learnings from their home improvement project, with the goal of helping and inspiring all of us. If you've ever managed a renovation or construction project, you know that the process is rarely, if ever, easy, and almost rarely goes according to plan. I want to welcome Roger Wiegand, Bill Churchill, and Sarah Maas Scheuplein. They will each take 15 to 20 minutes to describe their improvement project. And then we will have 15 to 20 minutes or so for questions and discussion. I invite you to post your questions as you think of them, and we will then pose as many of them as we can after we hear the 3 presentations. Our first presenter tonight is Roger Wiegand. Roger is a retired molecular biologist who lives in Wayland, and he's lived there for the last 20 years. An avid woodworker and do-it-yourself remodeler, he collects and restores mechanical musical instruments and supports the family efforts at converting the meadow surrounding his house to wildlife-friendly native plants. We applaud that. A lifelong believer that anything worth doing is worth overdoing, he has tackled 2 major home energy retrofit projects: a no-holds-barred effort on his own home and a highly budget-conscious project on his son's house. He believes in building not just for the next owner, but for the next century or 2. Welcome, Roger. We're delighted to have you with us this evening.
So Thank you very much. I'm delighted to be here and delighted to be able to share our project. We were pretty excited about doing it and actually managed to have fun through the process. So I'll begin sharing my screen here, and with luck, we'll start at the beginning. Okay, so tell me if you're not seeing my title slide. Everything's good. Okay, great. So I'm really going to focus in my talk today on the subject of insulation in trying to accomplish energy savings in a home renovation project. And I'm going to tell you about two different projects, as Jeff just mentioned. One on, I'm going to start my timer here. So, sorry for that. One on our house, which is really a pretty, I'll call it a luxury project. It's meant as a house we're going to live in for a very long time. The other is our son's house, where he really didn't have that much money, and we needed to keep everything to the bare bones. So I'm going to talk a little bit about project goals and philosophies, principles behind insulation, then describe the two projects, and then close with a few more thoughts and some things that I probably would do differently if I were to do it again, which I'm not. So what we were all about in going into this was really refitting homes to make them comfortable and efficient. And interestingly, those things seem to very much go hand in hand. If you make your house efficient, it seems to become more comfortable, and which is a nice win-win kind of situation. So in doing that, we want to achieve sustainable savings of energy and then incidentally cost. So my thinking about that caused me to focus on passive systems with very long lifespans because they would continue to pay back, not just in the next 3 years or 5 years or 20 years, but on well into the future. And there are plenty of homes around us that are 200 and 300 years old, and I have aspirations for this one. It's important as we're doing this to make sensible choices on energy expended to achieve energy savings. It doesn't make sense to use the equivalent of 10,000 gallons of oil to save 100. And you have to be aware of that. And the other thing to be aware of is, as we go through these projects, is opportunity cost. So if we spend a whole lot of money on one aspect of the project and ignore some other aspect of the project, that leaves us in a less efficacious place than we might be. And finally, as Jeff also intimated, compromises with reality are inevitable, and those realities can take the form of budget, they can take the form of ledge, they can take the form of supply chain problems where you can't get the materials you want. And part of my philosophy, and not everyone shares this, is the do it once and do it right idea. So we really focus on using the absolute best materials and methods and not shortcutting installation at all, because I really aspire to build for a century or two from now. So why insulation? And air sealing, I should mention, is the partner of insulation. They're both critical. First thing you ever want to do in a house, if you're trying to save energy, is air seal it. Then you can work on insulation. Then you can work on other things. So it's much more efficient to stop heat from moving in unwanted directions than it is to either create it by burning fuel or to pump it around with a heat pump or an air conditioner. So if you just keep the hot air out in the summertime, or prevent the cold from getting in the wintertime, that's a very inexpensive and passive process. Putting in insulation in a house is a very durable investment in the property value. Again, it can last for a very, very long time. The side effect also of that is that you get rid of drafts and things like that that make houses uncomfortable. And amongst the various kinds of ways one can save energy, it's relatively low cost and relatively simple to do. It, of course, has its complexities. So how does heat move? There are three primary ways by which heat travels from place to place. Radiation is one that we experience every day when the sun comes out, shines in our window, warms us up. It's direct transmission through space. It's in housing design, you think about it as solar gain, and it's really something that you have to optimize by the design and siting of your property. It's not something within limits. You can do window treatments and things like that to change it after the house is built, but it's something you really want to be thinking about early on in the process. Not really so much a renovation topic. Convection is that air sealing problem. So it's transmission by moving air. So if you've got gaps in your windows, you've got openings, penetrations for fireplaces, or openings in the wall or in the ceiling for can lights, things like that. Air is physically moving from place to place and carrying a lot of heat with it. And you, of course, mitigate that by sealing process, so using caulk, foam, whatever you can stuff in the spaces to stop the air from going to place to place. And finally, conduction, which is transmission through solid surfaces. And this is where insulation really comes into play, blocking the transmission of heat through our walls, windows, etc. So the 281 Concord Project, which is the house we live in now with my wife, Jean, a very high quality forever home for us. We really intend to live here the rest of our lives anyway. So it's a retrofit of an existing home along with an energy efficient addition that we put on as new construction. We wanted our house to be readily adaptable for the possibility of reduced mobility in the future, and we wanted to control operating costs to the extent that we could. So willing to pay a little bit of money up front to have a low cost house to operate in the future. In addition to the house, we've got a 1910 barn, which I've converted into my woodworking shop. And I also have a fairground organ, which we had to build a separate unheated, unconditioned building for. I'll tell you up front that this was not a cheap project. We aspired to come in at the $300 to $350 a square foot kind of level. The actual ended up north of $450, and I don't even want to calculate exactly what it was. And that was with me doing very substantial amount of the work. I did all of the internal, all of the interior trim, for example, in the house. So, and the flooring and a bunch of other stuff. So the starting point for our project is a 1950 Garrison colonial house. Let's say it had substantial deferred maintenance issues. There were gaps around the windows, things were broken, drafty as heck. And also, you know, the things about the way the house was sited, which were not so great. It's on kind of sideways on the lot, with the end of the house facing Concord Road, facing east, and we couldn't see the best views on the property from the house. Very low ceilings, and as I said, outdated boiler, no air conditioning, minimal insulation. And the first winter we have it, we didn't live in the house, and we tried to keep it at 45 degrees to keep the pipes from freezing, and we spent about $600 on oil to keep the house at 45 degrees for a winter. So clearly at a livable temperature, that was going to be a non-sustainable kind of number. So the plan then was to do a deep energy retrofit of the existing house and then to add an addition. And you can see the floor plan here, the area outlined in blue is the original house. That's a 2-story house. We built a 1-story addition on the front of it. We stole the kitchen from the original house to turn into our master bedroom, added in this connector area a master bath and closet, and then built a large room on the front of the house, which has our kitchen and a nice seating area. So the other thing that the list allowed us to do was to situate the house such that it faces away from the road. So we're kind of sitting backwards on the lot and facing due south, which really facilitates the solar gain in the wintertime. And then we mitigate that solar gain in the summertime through a combination of some shading things and landscaping to have put in deciduous trees that will shade the house in the summertime. This design was done, I should say, by Bill Sterling, who's a Wayland architect, and he did a great job. Okay, so one of the things to be very clear about in talking about air sealing and insulation solutions is that there is no one right answer, and that most properties are going to require several answers. So in terms of doing the energy retrofit on the old part of the house, the siding was in pretty bad shape, so we're not losing too much here. We stripped off the exterior siding of the house and then built up layer by layer something that would give us a very good air barrier and insulation. So on the outside of the house, now we're cladding the entire outside of the house, wrapping it in 2 inches of this blue rigid foam. Then on top of that, a zip wall system, which is a relatively impermeable oriented strand board product with a coating on it that makes it quite a good air barrier. And then further, you tape the seams on that to seal everything up. On top of that, then you'll see a little bit, you can see in the bottom picture here, there's a rain screen to keep to allow the water from building up behind the clapboards and shingles, and then siding back on top of it. In addition to that, we went on the inside of the house. It had 2x4 stud bays, and we filled those stud bays with blown-in cellulose. So the total insulation in the wall is somewhere in the order of R30, something like that. Now in the attic of the house, and I'll talk a little bit more about this later, but we used spray foam at the ridge line because we were putting HVAC equipment in the attic. We wanted to bring the attic into the conditioned envelope of the house so that we weren't running our furnace in a 0-degree setting. And also doing this helps dramatically with things like ice dams. We used spray foam to seal the joist bays in the basement of the house. And then on the basement walls, which had no insulation at all, we used rigid foam and built out 2x4 walls inside of that. All of the windows in the house were replaced in this process. In the old part of the house, we used a Marvin Integrity fiberglass window, being sort of scrupulously careful about how they were flashed, caulked, and foamed to make them completely airtight, and really spent a lot of time and many, many tubes of caulk closing every penetration that we could possibly find. So the addition on the house was interesting because it was built in a factory. So we used something called panelized construction to build the addition. So basically the company that we worked with builds the whole thing in a CAD system, in a computer system. And then they have this gigantic computer-driven saw that will cut each of the pieces that's in the CAD diagram, stamp them with a barcode, the owner's name, and a wall section that they go in, and spit them out. And so the workers there will take the parts and load them onto pallets until the computer dings and say all the parts for this particular wall section are done. And then they take it, working indoors on a flat, square, heated platform, and assemble wall sections and sheathe them, and then they are spray foamed. And spray foamed insulation is added at the factory, and then it's shipped on a truck to our site. And what you can see in this top picture is just a pile of wall sections waiting to be assembled. This is not really sort of prefab construction. The plumbing and electrical are all added on site. So one of the tremendous advantages of this was virtually no waste. So they built the entire addition for our house, and the total amount of waste that they produced amounted to about 2 55-gallon drums. And that material was then used to heat their building. So it's also a parallel work stream because our carpentry crew was working on the renovation on site while the addition was being assembled in a factory up in New Hampshire. And so there was some speed advantage, we think, but actually it ends up no compelling cost difference. So you can stick build it or use this method and you'll come out about the same. Wanted to say just a couple of words about thermal bridging, because it is an important thing, and insulation in your stud bays is great. It's wonderful, you should do it. But if you really want to achieve much higher efficiency, it's not quite enough. The problem is that about a quarter of wall area in a typical house is framing members. And that wood is connected directly, it gives you a direct path from the inside of the house to the outside of the house. And wood has an insulation value of about R1 per inch. So it's not a great insulator. So it results in substantial heat loss. And you can see this thermal image of a conventionally built and isolated house where yellow, the brighter yellow to white is the heat loss. And you can see this picture taken from the outside of the house with a thermal camera. You can see every single framing member because they're leaking a lot of heat. And the way to deal with this is fairly simple, which is wrapping the house with a layer of insulation on the outside that covers all of that, all of those framing members. And in the case of our addition, in addition to the spray foam on the inside of the wall, we put an inch of foam on the outside, simply to block the thermal bridging from the framing. So in these pictures, you can sort of see the progression of the construction of the envelope of the house. So in the top left-hand side one is the most of the elements of the panelized construction have been set in place, bolted together, seamed and caulked and taped. In the picture beneath that, you can see that now we're adding that inch of rigid foam insulation over top of the zip wall to block the thermal bridging. Then finally, in the upper right, you see we're adding siding to the structure with a rain shield behind the siding, rain screen behind the siding to allow water to drip down behind the siding and escape the building if it gets in by wind. And then finally, in the very bottom picture, what the finished house looks like. In terms of mechanical systems, we're probably not as advanced in this as certainly as some of the other talks you're going to hear. We went ahead and used forced air gas furnaces and conventional air conditioning for our house, zoned using a combination of their two furnace systems in the house, and then there are zone dampers that allow us to further refine the zoning within the house. Because we built a very tight house, we needed to add a ventilation system to ensure that we have adequate fresh air coming into the house. So we have what's called an ERV, an energy recovery ventilator, to ensure that fresh air is continuously circulating in the house without losing the heat. We currently have a conventional tank gas hot water heater. We'll place it with an on-demand system almost certainly when it dies. That's what I put in our son's house, and they seem to be great. I think with any time you're building a tight house, and if you have combustion appliances of any kind in it, you want to be opting for the sealed combustion direct vent kind of appliances. So they're getting their combustion air from outside. So you're not drawing air from the inside of the house for combustion, and you don't have the risk of backdrafting and pulling carbon monoxide into the house. The one item that I will never give up is my gas range. Sorry, those who say we have to go all electric, but there are limits. And then finally, in the front part of the house, we use the Marvin Ultimate windows, which are their higher end window, less plastic showing on the window. We thought it looked better in the public front rooms of our house. And they actually match on the exterior. They look identical to the fiberglass windows. So what did we accomplish? The one measure I can show you is National Grid sends us out this summary of our gas bill. And this is from January, February timeframe, last year before. And you can see that we are using 145 therms that month of gas compared to, they pick a set of, it says 95 similar homes, an average of 2 miles from us. So the average amongst all of those neighboring houses that are about the same, matched to be the same size, was 450. So we're using about a third the energy of the typical house of our size and shape, which I'm pretty happy with. Okay, on to the next project. What are we doing for time? We used it all up. So that I've lost my chat window, that's the problem.
Sorry, Roger, you have about a minute if you want to just mention this, and then maybe we can
Got
cover
it.
a little bit more in the
Got it.
Q&A.
Okay, so in my son's house, we were really looking at a very low budget project. The main thing that I want to talk about here is that he has a very low slope roof that made the attic inaccessible. We couldn't use Maas Save for that because they couldn't get in there. The solution was applying rigid foam to the exterior of the roof, and we made that cost effective by getting recycled commercial roofing foam. When they tear off the roofs of commercial buildings, re-roof them, they take off and replace the insulation, and there's a place down in Framingham where you can buy it for darn cheap, so in big squares. So in terms of insulation, what we did was apply 8 inches of recycled polyiso rigid foam on the outside. The basement got EPS rigid foam, did DIY, do-it-yourself sealing of the joist bays with spray foam. That was a lot of fun. And then we got blown-in cellulose in the walls done by Maas Save. Did lots and lots of air sealing and applied better appliances and replaced steel frame single pane windows with some Harvey new construction vinyl windows. Thoughts, I think I will terminate quickly here. I'd say things we do differently. We probably should have thought harder about a heat pump instead of gas heating appliances. I'd say that writing the checks to do this was painful, but we have a really nice house now and can barely remember the pain. And with that, I'll close. Thank you.
Great. Thank you very much, Roger. This was excellent. A lot of information to take in. Roger will be available, as the other two panelists will, for our Q&A afterwards. And we're going to try to post as many resources as we can on our website, as I noted. But great presentation. I'm guessing that one of the questions that may come up during the Q&A, Roger, is if you increased your need or how you solved this problem of replacement air once you sealed up your house and the building envelope and whatnot. All right, our next presenter is Bill Churchill. Bill is a homeowner in Lincoln who has a recurring habit of building and renovating houses in the Boston area. Recent projects include relocating and updating a 1850s farmhouse, as well as designing a LEED certified super insulated house in Sudbury. Professionally, Bill has worked as an urban land economist, a property developer, and more recently as a strategy consultant to Boston area nonprofits. He has a lot of experience, years of experience working in housing development in a variety of ways. To feed his love of house projects, Bill completed the Sustainable Design Program at Boston Architectural College and was, for a short time, certified by the U.S. Green Building Council as a green builder. So we're delighted to have Bill. Take it away.
Thank you, Jeff. And thank you, Roger. I've been to green building seminars that were less well prepared and documented than your presentation here. So kudos. That was a very great presentation. I appreciate it. I'm going to go a little more big picture, at least to start, and follow up on some of the things that Roger said. I think he covered them all. As Jeff mentioned, I've done from scratch construction, and then this project I think you're seeing on the screen now was after the new construction, and it is a completely different. I mean, the physics are all the same, but the challenges are different when you have an existing structure. So I'll start with this one. So this was a house that was built, I think 1845, we don't know exactly when, and had been renovated at least twice. And the current, when I first saw it for sale, the general consensus was it should be torn down and carried away. So on the left, that's where it was, when it was next to the highway, and it was stucco. And then when it's finished here, we took it back to the clapboard and rebuilt the original farmhouse porch. You can go to the next slide if you want to. We also you can see the solar panels on the roof. So the left slide here was in the 70s when there was some renovation where they decided it had some porch railing without a porch. I'm not entirely sure what the architectural history of that design on the left is, but this was the sort of, it was a sad, hadn't been lived in for 12 years. And my recycling plan was to recycle the house. I just, having finished construction, it already had roof beams and ceilings and great interior elements here and there. So the plan was to let's recycle the house and accept the fact that you can't get the kind of results that you can get in terms of insulation and infiltration results that if you're building from scratch, you control all the elements. So we did decide we were going to, as you can see, I think on the right side here, it's right on, it's right on the road, that's the access road. It's on Route 2, basically. It was about 12 feet from Route 2 when we bought it. And so before we were going to renovate it and restore it, we decided we should, obviously we're going to move it away from the highway. So part of the process of how to take things off and then move it and rebuild it gives us sort of forensic architecture. You can see as you take it apart, you can see when they added indoor plumbing, when they added central heat. Windows had gone through several iterations, especially in the kitchen, where the windows used to go full height down near the floor. And then at some point they invented kitchen countertops and they no longer did that. So it was interesting that, and it was always the trade-offs, as we were talking about in reality, was on how much do you spend, how much do you throw out, how much do you try to reuse? What's the next slide there? So yeah, so in moving the house, it turns out you put them on a truck apparently, and there's a hydraulic lift and they roll it over. And this was after we'd taken off both the stucco and the clapboards and moving it down the hill. And houses this old, you don't just design a foundation for it. You actually dig a hole and then put the house on blocks above the hole and then plumb line down to figure out where you're going to pour the foundation. So we're basically, the house in Sudbury was super insulated, R40 roof wall systems, whole wall insulation. This one, as we started to take it apart, one of the reasons this house was in such good shape was because there was no insulation. What's the next slide? So here, this is slightly back. So the stucco, and stucco is interesting because it was invented, the metal they used to put stucco on was invented in the teens. And it was a big upgrade. It's supposed to look like a stone house. But if you have a stucco house of this era, you can't blow in insulate. It makes the insulation very tricky because the stucco itself acts as a vapor barrier, and you can't have your insulation up next to it because you get condensation behind where the wood in the wall is. So one of the reasons we took the stucco off was it complicated the notion of how do you insulate walls that would container walls there. So because that was the original clapboard, so we decided I couldn't reuse it. I did look at it, but that we would replicate that. What's the next one? So here, as we started, this was what the window, the big window you can see there. This is when they took an old, at one point, I guess it was the bathroom, maybe it wasn't the bathroom, it was a room off the kitchen and made it into a bathroom. So they took out the full height window, because you don't have full height windows in bathrooms apparently, and put a little window. This little square under the new window was the entirety of the insulation in the whole house. So that was it. This 4x4 square feet of very sad, wet looking fiberglass. That was all the insulation the house had. And the good thing is that the wood never rots. It dries to the inside at all times. But yes, for energy efficiency, we're guessing not so good. What's the next one? All right, so this is the kitchen taken back to its original floor linoleum, which goes, as you can see, goes all the way to the edge. And this was what you had. Basically, it's true 2x4s, but just planks, panels. You take off the siding. It dries very well, except on the left it was where the sink was. and that hadn't dried as well because of leaks over the last 100 and something years. So rebuilding this house was had to rope it back together. Go ahead, do this next one. So here we are. On the bottom right, you see in between and being up and being down, we put it up, it was left up on blocks for a few months. And I recommend this to all of you when you renovate. Put your house up on blocks because it's a lot easier to walk around underneath. It's like getting your car up. It's easier to get underneath, though that isn't always an option. So let me just jump to what we were talking about. Before we did this, we did a blower door test. And I've done that in both the houses. And it is, Roger was talking about the importance of infiltration and air sealing. In this house, we did a conventional blower door test blowing out, which is a big fan in the front door, creates a great deal of pressure. And you can walk around the house and you can feel all of the leaks of the house. You don't have to imagine them, you can feel them. The one in Sudbury, what we did was we hadn't finished the construction. We still had the spray foam people there. They brought a smoke machine, put it in the house, benign smoke, just a sort of special effects kind of smoke machine. They started the smoke machine and then used the blower door input. So they were filling the house with the air instead of exhausting it. And we had the contractor who said, it's done, it's well sealed. I did a good job with my spray foam on all the corners. When you have the pressure and the smoke machine in the house, you can walk around and you can see the black smoke exiting the places that they missed. And it's a very useful tool to find out. There are other smaller little light things to find out where the leaks are. But the leaking thing, one of my building science outcomes was that people over assume more value to insulation than infiltration. And a very small hole in your siding can undo 3 inches of rigid foam. So the insulation is great, it is important, but tight, the building envelope guys really like the tightness element. And as Roger pointed out in passing, you do have to put in a fresh air exchange system once you get the tight house. That was a mistake, think of 70s houses or some period where they got everything tight and then you had sick building syndromes. Anyway, next one. So insulation, we did the same thing. I won't spend any time on it. There were some parts where we blew in, we could blow in cellulose, other parts we used batting. The roof, all of the building science guys, the biggest payback, the biggest key ingredient is up. If you want to insulate the roof, attic with your heating systems in the envelope, the heat going up is going to be your biggest loss. And we put, I think, 4 times as much, I think Roger did too, at least on the son's house, 4 times as much insulation on the roof and on the walls. But then next. So I'm going to spend a little time on windows because that isn't something that is usually talked about as much, especially in renovation. So in new construction, you have the trade-off of, windows are heat, they just let out heat. No matter, I bought for the new triple pane gas-filled windows, they still didn't get above R5 or 6, no matter the best in the country, R5. And the worst wall in the country is R5 or 6. So windows are going to be heat loss. And you can get the solar gain, you can get energy efficiency because the windows give you light, so you don't have to turn on the lights as much. But in general, they're going to be a loss. So and the cost of upgrading windows, I planned on this house to repair the ones that were here, but they had rotted too much. The reason I wanted to repair them was Historic New England, and I can give later a link to that, but Historic New England has done 4 or 5 projects with white papers, trading off between repairing historic windows and replacing them. And the repairing with an interior storm screen was the option they ended up with, because they could get it with really good sealing, and first they repair the sash, hand repair the wood sash, especially in these old buildings that can be quite beautiful, good hard wood. And then an interior storm screens, storm screen system, mostly storm, and that's up in the winter. And so the outcomes are comparable to a double pane window, but the repairability is way higher on a screen and original window. If you have a thermal pane window with at some point on many, 1 out of 10 maybe, the seam will fail within the first 10 years on some of the windows. So once your seam fails and you get, I'm sure you've seen them, they get sort of cloudy, and that's a throw out the window and start over. Whereas the storm, so that I had been inspired by their work, so I was hoping to do interior storms. What we did was, I think the same window that Roger mentioned was the Marvin Integrity with the simulated dividers, so you get the Munyon look of the old house without actually, but it's one pane of glass. And so yes, you can get a good looking, for historic homes, you can get these. They're simulated light divide, so that it's one pane of glass, but they have the Munyons on both sides of it. So I'm sorry, with the next one there. So the next part, we have a carriage house, and this one we did, slightly different approach. We still had blown in cellulose for the ceiling part. We had some spray foam. The bottom of that sort of addition there that was unfinished, we wanted to make it finished. So between insulation of the ceiling, the roof, thermal paint, and that's me crawling under doing the part. Roger said it was sort of fun. The DIY foaming kit to insulate the floor from below. And yes, it never got to be, LEED certified. It wasn't super insulated, but it insulated a 3-season porch to make it 3.5 season kind of thing. And so yeah, so once you insulate it, then you have to both tighten it in for the wind doesn't blow through, and then keep vented so that there is some air exchange in it, and then plant native plants that Stephanie did on the outside there. So this is the thing about the windows is that it's really important to figure out what your goals are and where they are, and make sure that the insulation value, it's good to get a good fiberglass, because it expands and contracts at the same rate of glass. Those frames are excellent, but the idea of how do you get the benefits of the light and really focus on sealing, as we talked about earlier, making everything tight. This, I think this is a little clip that I think you can play that. Can you play that, Steph? We've lost your audio though. There were a couple of clips coming from there was a short-lived program called This New House, and so they liked all the strange and crazy things I was trying to do in the one there. But one of the lessons from that, which I think applies to renovation as well, is if you do the insulation and the infiltration really well, the decision you make about your heating system becomes much, much less important. If you're having to heat a very leaky old house with huge ceilings and lots and lots of rooms, the heating system, heat consumption is everything. The serious building science guys and like the German standard of the passive house, all that thing, all of those, if you can heat it with nothing. The source of your fuel to heat becomes almost irrelevant if you're using so little of it. And that involves really good insulation, really good air sealing, and going a little back to what this house had in the beginning, which was rooms you could close off. So you're basically heating the room you're in, as opposed to heating the entire house if anyone's home. So just heat yourself, heat where you're using, insulate well, and cut down on the leakage. We can try
I see
it.
you, Francesca. Love the energy today. Climbing
The Sudbury Steelhouse is the latest in strategic design. From its modern look to its innovative take on energy efficiency, it's loaded with cool ideas you can use in your own home.
These days, the latest word in windows is tuning. For each side of the house, there's a window that fits the conditions perfectly. Here on the south side of the house, these windows are built to take all of that low-lying winter sun in and maximize the solar heat gain. On the north side, there's just enough windows to brighten up the place, but these babies are all about insulation. But all this tuning takes a little technology. Look at this. There's several places where you can put a different metallic coating on the inside of the panes of glass. And on this window, there's also 2 pieces of film. Now those things are going to help determine how much light can come into and stay in the house. It's amazing. Windows with an R value as high as some walls, and you get your gorgeous view. Now, if you tune your windows, you can save up to 30% on your energy cost. I'm thinking my house definitely needs a tune-up.
Some of those options are harder to find even at the Marvin high-end window, but the principles are there. So I'm going to stop there and we'll take questions later. Thank you.
Great, thank you. And just to confirm, Bill, the video clip we just saw with the windows, that's the house that you designed and built in Sudbury, is it not?
Yes, that's it.
All right, that something worthy of discussion later, since it looked like there were a lot of great design elements and energy efficiency principles incorporated into that home. All right, our final presenter for this evening is Sarah Maas Scheuplein. She combined a longtime interest in environmental stewardship with a diverse background in science and research into a career in sustainability with a special interest in green buildings and sustainable communities. Sarah is also one of the organizers of the Weston Plant Pollinator Alliance, a local conservation group working to build connected native plant habitat to restore biodiversity and protect threatened native pollinator species. In just a moment, I will post the website that Sarah helped build for the Pollinators Alliance, since it's an excellent local resource for people wanting to learn more about protecting and supporting indigenous species. Sarah moved to Weston in 2019 with her husband and her 3 cats, and they have undertaken several home improvement projects to decarbonize and electrify their home, including a very impressive geothermal heating and cooling project that she will be discussing tonight. Sarah, welcome.
Great. Thank you so much, Jeff, for the introduction and for the opportunity. First of all, thanks for the plug for our Weston Plant Pollinator Alliance. Today, I'm going to be sharing our experience converting our oil heating system to a new geothermal heating and cooling system. I'll also share some additional energy efficiency measures that we undertook at the same time to further reduce the environmental impact of our home. And actually, this is good timing. This is our home right here. Next slide, please. Perfect. To begin, I just wanted to share some background and context of the existing systems and the conditions when we moved into the home in July 2019. So as you saw from the picture, our home is a cape that was built in 1950. It has approximately 2,500 square feet of finished living space with 4 bedrooms, 4 baths. The home and the existing systems had been well maintained throughout its lifespan so far, and it had undergone several updates, but no major renovations that drastically changed the layout or the structural organization. So essentially, we're still pretty much dealing with the 1950 floor plan, which, we're actually okay with. But unlike Bill and Roger, we are not undertaking a huge renovation. We're kind of working from the inside out. So the existing heating and cooling system consisted of an oil furnace. I'm showing you a picture of our old furnace here. It had been installed in 2004 and was 15 years old at the time we moved in. So we knew that it was getting toward the end of its life expectancy. We also had central air, we had 1 condenser outside. And you can imagine we were a little bit disappointed to learn that upon moving in July, first the cooling and then later the heating did not work well at all in our entire 2nd floor. So we did know that replacement of our system was imminent. Fingers crossed, we do plan to stay in this house long term. So we realized we were in a position to make a big change with positive implications, both for our own comfort and lifestyle, but also for the environment. We began to explore more sustainable options for the replacement HVAC equipment that would allow us to not only reduce our household greenhouse gas emissions, but also to hopefully eliminate fossil fuel usage. And as many of you here probably know, the obvious choice was to switch to a heat pump system for heating and cooling. Next slide, please. So this is a lot of information. I just wanted to, I know many of you are familiar with heat pump technology, but I've compiled some of the pros and cons of each type just for comparison. And so you can kind of get a sense of the factors that went into our decision, that what was best for, our personal situation. Geothermal heat pumps, of course, work very differently from traditional heating systems. Instead of generating heat through fossil fuel combustion, they move heat using electricity. So they come in air source or ground source, also known as geothermal. These both rely on refrigerant compression and expansion cycles and heat exchange, of course, as the names imply, either in the air or in the ground. And because of this difference in the mechanism of how they transfer heat versus generating it, they're very highly efficient. So 400% efficiency is pretty standard for these systems. One thing you have to keep in mind is they're very efficient at maintaining a set heat. But unlike traditional heating systems, they're not good at heating a space quickly. So you often hear the phrase, set it and forget it. And I will tell you, this is, does take a mind shift. So it takes some getting used to. So I want to say, first of all, that we were interested in replacing our system with a whole house system that would tie into our existing ductwork. And even though we had said this to all of our installers, the air source heat pump installers that came all tried to push the mini split systems. And I have to say, we installed those in our previous house in Arlington, and we really liked them for that house, but that just wasn't the best solution for our relatively closed floor plan. An advantage is they're affordable, quick installation, but one issue we ran into, because we, unlike Bill and Roger, we don't have a super tight, perfectly insulated house. They recommend often in retrofit situations that you should at least at the beginning keep your existing heating system as a backup, especially for really cold days. So we didn't love that idea at all. Finally, there's some outside equipment that could be susceptible to damage, and it does generate some noise, although it's pretty quiet. The ground source heat pumps, on the other hand, the geothermal, mostly in retrofit situations, they always do, or, very often do a whole house ducted system. For new construction, you can get radiant heat, but that's obviously a lot of work for retrofits that aren't equipped for that. It is, the biggest drawback really is that it's a longer installation process and it's a higher upfront cost. Because they rely on constant ground temperature, which here is around 50 to 55 degrees. You don't have that temperature fluctuation that air source heat pumps can be subject to, at the temperature extremes with really hot or really cold days. So for our personal situation, the geothermal would allow us to completely get rid of our oil. We wouldn't need a backup system. There was no outside equipment. So, even though the geothermal system would be more expensive up front, it provided us the opportunity to completely eliminate fossil fuel usage for heating and cooling our home. Next slide, please. All right, so here's just a brief, more in-depth look at how geothermal heating and cooling systems work and why they're so efficient. So geothermal heat pump systems circulate a water or antifreeze solution through piping buried in the ground, either in vertical boreholes, long, narrow horizontal trenches, or an existing groundwater source. And they can exist in either closed or open systems. Of course, this all is attached to a central heat pump unit. And I should say, in Massachusetts, the most common type installed in residential properties is the vertical boreholes in a closed loop system. So in winter, the circulating fluid absorbs heat from the ground and then transfers it into the house. While in summer, this process is reversed and the circulating fluid absorbs heat from the ground and transfers it into the house. Or sorry, I said that the other way around. In summer, the process is reversed. The heat is transferred from the house to the ground. Because of this, geothermal heat pumps are substantially more energy efficient than even air source heat pumps. And as I mentioned, they do take advantage of the relatively consistent ground temperatures, which are far more uniform than air temperatures. Next slide, please. So we're often asked, the cost is a big consideration in installing a geothermal system. So here I've included a breakdown of costs just associated specifically with installation of our system. And just so you get a point of reference, again, our house is relatively small compared to many, but we also chose to install or to replace all of our old leaky, unbalanced ductwork. You know, we thought if we're putting in this really efficient system, why would we keep that and, you know, lose efficiency that way? So this price does include all new ductwork for the basement and main floor. And then, as I mentioned, we had to add a second zone so that our second floor, which has 3 bedrooms, an office, and 2 bathrooms, would also be really comfortable. So that had all new ductwork as well. So the costs on the left, you can see design and planning is actually a relatively small part of the budget, but it's really important because that includes some energy modeling. So, you know, you want to make sure that your system is appropriately sized to work the most efficiently for your, you know, the heating and cooling needs that we had. You know, the other line items, the equipment, materials, and installation, the drilling and pipe installation, and the ductwork and refrigerant lines are all, you know, a hefty part of the price tag. It's, you know, 30% to a third of the whole entire budget. And I do want to mention this number does include $12,000 for replacing all of our existing ductwork. We could have, you know, left that off if we wanted to keep our old ducts. However, we're very lucky to live in Massachusetts, where we're eligible for a lot of federal and state credits and rebates. So we were able to, you know, obtain the 26% federal tax credit for renewable energy installations. This is, the 26% is going to continue through the end of next year for installations, and then it will go to 22% after that. We also got the Massachusetts Clean Energy Center rebate, and that was based on our system size. This does not exist anymore, but I believe there's an equivalent one through Maas Save now. And finally, our geothermal installer was able to obtain alternative energy credits from MassDOR on our behalf. So you can see those credits and rebates really bring down the cost substantially. It's still, you know, a hefty upfront cost, but we do anticipate, you know, like you've heard by the previous speakers, we anticipate being here for a long time, and the upfront cost to us is worth the, you know, the long-term benefits. Next slide, please. All right, I wanted to take you, you know, for a few minutes, take you through, kind of walk you through the process of what it was like to install the geothermal system at our property. So first of all, 2 450-foot boreholes were drilled in the front yard, approximately 20 feet apart. As you can see from these pictures, the left one was taken from inside the house, the right one from the street. The drilling equipment does require a lot of vertical clearance. So we did need to do some additional pruning and removal of one tree that was unhealthy anyway, so that the equipment could access the desired drilling locations. Also, probably like many of you, we live on a scenic road and had to get an additional permit from our planning board to temporarily remove a portion of our scenic stone wall for access. This was later rebuilt exactly as it was before. And actually, I should mention, this was done in early March 2020, the drilling. Next slide, please. So next, the vertical loops seen here had to be connected via trenching. And this was done in kind of mid to late March 2020. So you can see the vertical loops. Those were the boreholes that were drilled before. They've been installed to the proper depth, but you know, tubing had to be run to connect everything together into a closed loop that entered the house. So it is really important, the tubing has to be buried below the frost line. So these exposed visible, you know, sections of the wells that you could see, they were actually cut off 4 feet below the ground surface. The geothermal pipes were then connected to each other via heat fusion. So, you know, it's supposedly leak-free technology, and brought into the utility room through our basement wall. You can see that in the right picture. And then once the tubing was laid and, the ends were brought into the house, it was all buried. And, once the pipes are buried, it can be landscaped over. They don't recommend planting trees over, but otherwise you can do pretty much anything else. And it will eventually be completely invisible. So the boreholes and the tubing are expected to really last more than 50 years. So you do get hopefully a good return on investment for that part. Next slide, please. All right, I just wanted to give you kind of an overview of the equipment that was installed. So we had the ductwork and equipment installed in June 2020. So that was, quite a bit later. Of course, we were dealing with COVID and, lots of other things going on. They weren't making home visits at the time. So even though it's a longer process, this was an especially long process. The equipment that we have, I've listed here. We essentially have a packaged geothermal heat pump unit. This contains both the air handler and the compressor in a single unit. And that serves the finished basement and the main floor. And then, as I mentioned, we had issues with the heating and cooling of our second floor. So we also installed a second zone, a split unit, which is the compressor number 2 is in the utility room and the air handler is in the attic, and it's connected, with refrigerant lines similar to an air source heat pump mini split. We also, I just am showing a picture of all of our old leaky ductwork that was waiting to be transported to the scrapyard for recycling. I've also included, for anyone interested in kind of technical details, some of the information about our systems. Essentially, that's just measuring the performance and efficiency of our system in heating and cooling. But one thing I do want to mention, kind of echoing the other speakers, not everything always goes perfectly. We did make a mistake. I just want to say the picture of, number 3 of the air handler in our attic was taken very recently. So if you go to the next slide, what we found, unfortunately, is that we had a delayed realization that we were experiencing heat loss from our attic. Previously, our attic was, unfinished, unconditioned space. And we did have a lot of attic floor insulation, which was perfectly sufficient for our envelope at the time. But the addition of the air handling unit changed our envelope. So we realized, oh no, that's not very smart. At the same time we noticed that, we hired an infrared thermal imaging auditor to help us identify additional insulation issues that could be addressed at the same time if needed. And I do want to mention, Bill talked about this, but our auditor would have done a blower test at the same time, but we know that we have small amounts of vermiculite in our property, or we did at the time. So that's obviously not recommended to have a blower test with vermiculite. So be sure to keep that in mind before scheduling one. Luckily, we didn't have any additional major issues discovered. We did add insulation to our attic rafters in March. So we feel pretty confident that we're, kind of set now to move forward. So if you go to the next slide. I know you're probably wondering, okay, this is all great, but what's the return on investment? What's the cost and energy savings? So because, as you probably gathered by now, we changed a lot of things. A lot of variables were changed in a very short amount of time. So I will show you data from our house, but I first wanted to show you just an example that's very similar to ours. This is real data from a house that's equivalent size to ours with similar climate, 15-year-old oil furnace and central AC. So in this particular case, they had a good comparison before and after without changing anything. And, they were paying $3,400 annual total heating and cooling costs pre-geothermal installation, but they saw 46% savings after the geothermal installation. And this is pretty typical. You read a lot that people immediately see savings of 40 to 70%. So that's pretty huge. Just the next slide, if you go, there's a lot of information here, but this is actual data from our house. So I'm showing you, first of all, the household electricity consumption per month from the time we moved in till, our last electric bill a couple weeks ago. And this is in kilowatt hours. So this is our consumption. I've also highlighted the heating seasons. We had one winter before the geothermal installation and one after. And kind of as expected, you see that after the geothermal installation, you see a really sharp increase in electrical consumption. This is not unexpected with the geothermal mechanism of action. And, we did add a second heating and cooling zone. And one thing I didn't say is that our overall temperature maintained is also much higher. We previously had a 10-degree setback at night, but we don't do that anymore with the set it and forget it. So one interesting thing is that I've also highlighted, we've had now 2 cooling seasons with the geothermal, one without insulation and one with. And, kind of echoing what Roger and Bill already said, we do see that with insulation, this is really a direct comparison, that we're already seeing a 20% reduction. I put costs, but consumption and costs with directly related to the insulation installation. Next slide, please. All right, just very quickly, the other half of that is, what about the costs? So I'm showing here a graph, basically the same time frame, but this is the dollar amounts of electricity and oil together. So unlike the previous graph, we can see that actually when you take oil into account, for that first winter, the costs are much higher. So we did see, even though we changed all of this other stuff, we did see about greater than 10% reduction in heating costs already. So we are very excited to get through this winter to see what the insulation does. Just very briefly, I know that some of you may be wondering, we did end up installing solar as well. So the costs I'm showing you here are actually for those asterisk months at the end there. Those were calculated based on the monthly utility rate per kilowatt hour and actual consumption. So they do not reflect reductions from solar production. So last slide. I know I'm almost out of time here. I just wanted to, emphasize that converting to geothermal was a large undertaking, but it is already showing apparent reductions in energy use and costs. One thing I do want to mention, just the last thing, our house is fully electrified. That's not necessarily by choice. We actually don't have natural gas in the street. So I hear you. I know a lot of people like Roger love the gas stove, but I was one of those as well. But we don't have an option here, so we've adjusted. There's definitely more work to be done. These other speakers have really inspired me to, there's a lot we can do to further decarbonize our home and really reduce our environmental impact. So that's it.
Great. Thank you very much, Sarah. Wow, lots of interesting information. What a great project. We've heard now from our 3 presenters, some things in common: insulation, building envelope assessments, and tightening up the building envelope. Challenges along the way. We have some time for questions and answers. I also wanted to just make sure that we, Stephanie, let me ask you this. Bradley Hubbard Nelson from the Heat Smart Alliance is here this evening. Would it be possible to let Bradley just say a word or two about the Heat Smart Alliance, since it's pertinent to our program this evening? There's Bradley. Bradley, are you there?
Yes.
Good evening.
Hi, I'm Brad Hubbard Nelson. I live in Concord, and we formed a group 2 years ago called the Heat Smart Alliance, and we started it. We did the Maas CEC heat pump Heat Smart program in Concord, Carlisle, and Lincoln. And having learned that, but it was a limited time program, we got together with groups in lots of other towns where we have people in 25 communities around the greater Boston area. And so our mission is to help people with assessing whether their homes are good for heat pumps. It's always a bit challenging because every home is different. So we do coaching of residents. So first thing I'd like to tell you is that anybody who's thinking about installing, whether heat pumps are right for their home, they can consult a volunteer coach. We're all volunteer, and we're not, we don't represent any commercial interests. And so balancing, is insulation right? You have to do that first, heat pumps, what type to think about? Because there's a lot of questions to answer. And the other thing I'd like to tell you is we're having a lot of fun with this. And if you are into helping people understand the heating and cooling in their homes, we'd be very interested to have you check us out, because we do coaching, we work on policy, we do some research on energy efficiency of heat pumps versus other solutions. We have some very interesting working groups. So we meet once a month over Zoom at this point, but then we have working groups that meet at other times. I'm going to just tell you the email address, info@heatsmartalliance.org.
Great.
And you can contact us, or you can go to the website heatsmartalliance.org, and it's a pretty good website to tell you how you could get involved with our group. We aim to help Massachusetts, work on its climate and energy goals, and help people do the right thing.
Great. Thank you very much. And let me just note that we have posted the email that Bradley just mentioned, and we also posted the website for the Heat Smart Alliance, which has a lot of excellent resources. It's shared here, and it's also already up on the Metro West Climate Solutions website on the resource page as well. We do have several questions. A lot of them are like, I think all of them are basically of the theme of, how do I do this? I have X challenge in my house. What would you recommend? So Joel says, we have an 1890s house. Congratulations, and I'm sorry, Joel. Single pane windows with external storms. Sounds familiar. Better to replace with new double pane windows, he asks. Bill, any thoughts about that with respect to historic preservation and our values? And
I would, like I said, I think you can post, or you will be able to post the white papers of Historic New England that address specifically the sort of trade-offs here. The trade-offs they go with, obviously, because they're Historic New England, is they always want to do as much as they can to preserve the windows, and the interior screen storm system compared to the exterior is both less visible to the outside, and it gives equivalent outcomes for them. It's an equivalent cost as putting in your thermal pane. So it isn't obvious. It depends on the condition of the window and the urge or not to preserve them. They have done a system where their interior storms are very tight sealed, and they take them down in the summer. So basically, there's a storage issue. They don't really open and close very easily. They're sealed during the heating season and removed during the other. So as I said earlier, I think the double pane, good quality ones are expensive, and they still have a failure rate. So if whatever you do, it's still the key is the sealing of them.
that brings up an interesting question, though. The more that you tighten up a house or a building, and the more you introduce these fairly complex heating and cooling systems in the way of geothermal, it requires ongoing maintenance and ongoing monitoring, if you will. Do you find, let me ask the three panelists, do you find that you're monitoring your building, your house on a more active, regular way than you were before your project? Even with respect to heating and cooling, with respect to seasonal alterations or adjustments in your house for indoor air quality and the like. I know, like, replacement air and adding mechanical ventilation it increases as a concern or as an objective the moment you really tighten up your building. What was your experience with that?
Are you asking someone in particular?
Like
Roger, you talk about your ERV, because I think those are
All right,
all everywhere. And but what was your experience?
So our experience so far with the ERV is quite good. We don't have a real fancy unit. It's basically a box with 2 fans and a heat exchanger in it. So it's pretty straightforward from a technical point of view. Maintenance is taking that heat exchanger out and washing it out once a year.
So let me just break in for a minute, just so when we talk about ERV, or they used to be HRV, or Falpic recovery ventilator, whatever they are, it's basically a controlled system of getting fresh air and stale air, fresh air in, stale air out. And the reason it's better than just opening your window, which is another way to get fresh air in and stale air out. But the way this does it is it mixes the temperature of the outgoing air with the temperature of the incoming air. So in the summer, you've cooled your house, that cool air pre-cools the incoming air, and in the winter, the heated air preheats the incoming. So it's just a much more efficient way to do an air exchange than to open windows on both sides of the house, which would be another, or just let it leak like the older houses do.
Yeah, you can retain about 85% of the heat by pushing it through one of these devices. We've had to replace one of the fans once in 8 years now.
I mean, they're very simple equipment. I mean, there's a fan,
relatively quiet. It blows all the time. We did not put in. Some people put in separate ducting systems. We did not do that. We just fed it into the furnace ducts of the house, and that seems to be working just fine.
So speaking of ducts and air systems, Elizabeth says, I'm wondering if you have recommendations for who to go to for air sealing insulation projects. I am inspired by all these wonderful ideas, but don't know which companies are the recommended places to go to get this done right. I agree with Roger. Do it right the first time. Thank you.
Well, I would say start with Maas Save.
Maas Save.
It's a great program. They'll come out to your house, give you an evaluation for free. They will come out and do a lot of air sealing and a lot of insulation. I think the benefit is on the order of $2,000 a year worth of work. So if you do, the last week of December and the first week of January, you can get $4,000 worth of insulation work done. Great program, and I would start there.
They usually give you then a list of contractors, accredited contractors, and then you can go through and get several bids and talk to them and find the one who you think is going to work well for your project. There are some local contractors working on insulation I've heard of around here. I'm not going to get into that tonight, but feel free to follow up directly. Holly says, great projects, everyone. Thank you. I went through a deep retrofit renovation myself. One subject I haven't seen addressed is eliminating skylights. I had 13 in the home I bought 9 years ago, and they were major sources of heat loss. The light from them is nice, but I eliminated them all in my project. Any penetration through the roof. I mean, we talked about the importance of a high R value in the roof. Any thoughts about skylights?
I really don't enjoy water running into my house, so I don't make holes in the roof if I don't have to.
Yeah, they're a perennial source of leakage even before we got into but as I said, the windows are terrible insulation devices, and your roof is your most important insulation need. So I agree that there sometimes they have to cut them in because it makes living space, but it's best if you can avoid them. Yes, I agree.
Yeah, I'll just add, we have existing skylights, which we are keeping because our house does have a very kind of closed floor plan, lower ceilings, and they do cause probably some, not water leakage yet that we've noticed, but we like them for the light. So those are staying.
Great. Holly says Callahan's Energy System, as a company that she's used on 2 homes, does deep energy retrofits. I'll also note that Green Stamp Insulation in Waltham, they're more a commercial outfit, but they do excellent work locally. I've seen it and observed their guys, their technicians at work. Joel asks, we have a gas forced hot air system. If we install a whole house air source heat pump to replace the gas furnace, can we use the old ductwork to save money? Or will it work okay?
I can answer part
yeah.
of that. Joel, one thing we had looked into is there's actually maybe Bill or Roger has more information, but there's a substance that you can kind of inject into your ductwork that will seal any leaks. And I don't know, about the air quality issues and stuff like that, but that's something that is often done. That was recommended as an alternative that from our thermal energy auditor. We did decide to go with all new ductwork, but I think there's ways that you could make it work. And I don't know if Roger or Bill has more to say about that.
I'd say the main thing is to keep your ductwork inside the conditioned envelope of your building, and then it really doesn't matter whether it leaks or not.
We had to replace the ductwork in this house because it was only for heat, so they were much smaller, and they had been sort of retrofitted when they decided to put them in, and they snuck them in between the joists, and it wasn't very good. It didn't work for air conditioning. Worked for heat, but not for air conditioning, so we had to replace it.
There are contractors out there who specialize in ductwork sealing, as Sarah described, and you can get bids to do that. I think Maas will recommend that in certain instances. The ductwork insulation is crucial as well, especially if it is outside of the climate or the heated or treated air area, since there's also condensation to be, which is legitimate concerns with that sort of arrangement. Okay, I think, are there other questions or comments? I don't see any, so I think just one other question for Roger. Did you use a blower door test at all in any of your work, or did you not even?
No, we didn't. In this house, the wind was whistling through the house. It was perfectly obvious that there were plenty of holes. And by the time we got to the end, we had enough things to spend money on that we just didn't do it.
Roger, Bob wants to know the name of the secondhand insulation company in Framingham you used.
I'm going to have to look that up and
right. We can get that to you, Bob. Yes, and you said 8 inches, right? You put 8 inches on the roof, your son's roof.
Yeah, correct. Of polyiso foam, which is actually a higher insulation value than the EPS foam that you commonly see.
Great. Okay. I think we are going to conclude this evening. I want to thank all 3 of our presenters for very substantive and fascinating presentations tonight. We will have a recording of this on our website. Should be posted by tomorrow or Thursday at the latest. Let me also just note here in closing that on Wednesday, December 15th, there is a chance, an increasingly growing chance, that we will be hosting a program on greening the holidays at 7 p.m. that night. It will be fun, it will be festive, it will be informative, and it will have several ideas and suggestions for how we can all green the holidays, including the obvious one, which is shop local. There may even be some information or some encouragement to advocate for the bottle bill, which is a perennial challenge here in the Commonwealth to get a common sense bottle bill passed. I think that's it, though, for tonight. Thank you all for coming.
Thank you, everyone.
Staying. Thank you, Bill. Thank you, Roger. Thank you, Sarah. And have a good evening.
Thanks for having us.
Thank you.